Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I'm excited to welcome Benjy Weinberger. Benjy, thank you so much for joining us.
Thanks for having me. It's great to be on.
Great. So please just go ahead and introduce yourself.
Sure. So my name's Benjy. I am the co-founder of a startup called Toolchain, and we're working on a distributed software build system based around an open source core. I've been a software engineer for over 25 years now, and I've been really focused on the software build space for probably the last 10 years or so.
Great. And during the prep call, we talked a lot about build system in general, and the one that some of our listeners might know about, might not, called Pants. Can you give us a history, how it came about and where it's going?
Sure. So Pants was a system that started out as an internal system at Twitter for building Scala code at scale when your Scala repo gets big. And that project was initiated by John Sirois, who is now my co-founder at Toolchain. And I joined Twitter and encountered this system and was pretty excited to use it. And I needed to change it, kind of add some features, and I got connected to John that way. Fast forward a bit, after I left Twitter, I went to Foursquare, and Foursquare had a similar set of problems with scaling its Scala builds. So I reached out to John and suggested that he get approval to open source Pants, and we could collaborate on it in the open, which is exactly what happened. And that's how the Pants open source project was born, initially with a focus on Scala builds, and it eventually expanded to other languages. So several other companies also got involved. Fast forward again to more recently, I had left Foursquare and I realized that build systems and sort of what the next generations of build systems should look like was a topic that I was really interested in and wanted to work on and contribute to. And meanwhile, the code in Pants was getting quite old and long in the tooth, and we had learned a lot from building it. So we started working on the next generation of Pants, which we unimaginatively refer to as V2. We launched that last October. It is basically a complete rewrite of the system based on the principles and lessons we learned from years of working on that V1 system. One of the big differences is that the initial use case that we used to drive this development was Python, because in those intervening 8-10 years, Python has really exploded in popularity, and the idea of having large, scalable Python code bases that span multiple libraries and multiple projects with a lot of shared dependencies is now quite common, which it maybe wasn't back then. So although Pants v2, we are working on support for other languages, notably Java and Scala, but at the moment, the focus was on Python. So that's kind of where the Pants project is right now, relaunched with brand new technology built in a combination of Rust and Python, and with a focus on Python as the target language.
Great. In the prep call, we also talk about the technology of Pants, and you mentioned that it's rewritten in Rust, and just by rewrite also sounds scary, I guess, to a lot of our listeners. Any regrets or lessons learned from doing that rewrite?
I call it a rewrite, but really it is a new system with new technology. The old system was a bit of a hybrid in terms of its model. The new system completely embraces the workflow model of builds. So if you think about older systems like Make or Maven or SBT or several generations of these systems, the state of the system is essentially the state of your file system. It's basically to know what the state of your build is. Nothing is explicitly modeled. Pants v1 was kind of a half step between that and what we have now with Pants v2, which is everything is modeled as workflows. So your build is broken down into a very large number of small steps. We call them work units, small tasks. And each of those is fully specified by its inputs and outputs. Everything is explicitly modeled. And what that allows you to do is it gives you very fine-grained invalidation, because you can exactly track dependencies and how they affect build work. You can cache, because you can know all the inputs and you can fingerprint them. You can run concurrently because, again, every piece of work is fully encapsulated. And so you know all the dependencies. And so you know what can be run concurrently. And finally, you can run build work. If you have the right setup, you can run build work remotely. So your concurrency is not just, I have 8 cores, so I can run 8 tests at the same time. It's maybe I can run 100 tests at the same time because I have this cloud. this cluster that can accept and perform that kind of work. So V2 is not just, well, V1 we wanted to rewrite it in Rust. It is really a brand new system that shares mostly a name and a sort of community and user base with the old system, but not that much more.
Hey everyone, Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. And when talking about Python and how it evolved and the ecosystem around it and all that, at some point you also mentioned, I think, Monorepo. How do you see that? I mean, for some companies, it's something that they are maybe using for a decade or more. In the industry, there is a heated debate. There are opposite sides of, what it brings, what it doesn't. I mean, with your experience in build systems, what's your position on that?
So I do have a fairly strong opinion, but I would preface this by saying that Pants is not exclusively for monorepos, but it is exceptionally useful in monorepos. And here's my opinion on the monorepo debate. Obviously, every case is different, but I would say this. Scaling your code base, the difficulties come regardless of your architecture, whether you choose monorepo or multiple repos. The problem comes with analyzing changes and how they propagate through your dependencies. And you can't architect your way out of that without the appropriate tooling. So you will have this problem in a monorepo and you will have this problem with multiple repos. Why I come down on the side of monorepos for the most part is that at least monorepos make that problem explicit. So your dependencies, your first-party dependencies all live in the repo with you. You can't just say, I'm going to make changes off in a corner, bump a version, and push the problem of upgrading to that version on my consumers. You have visibility into everything that depends on you, and you make a change, you have the opportunity to propagate the ripple effects of that change correctly in your repo. Obviously, this is hard to do without tooling, and Pants provides that tooling. If you're going with a multiple repo architecture, to some degree, you are kicking the can down the road to other people. And you're kind of atomizing your code base and also atomizing your team, because you're essentially creating a situation where there's no incentive and no tooling to even enable correctly propagating changes through your code base. So you end up with these little fiefdoms, within your engineering organization where different people kind of want local control of their little repo and everyone else can just suffer the consequences of my changes. So generally, I found that monorepos have advantages as long as you have the right tooling, and a lot of the work that we put into Pants is to provide that tooling.
Okay, great. That's good to know. And nicely laid down in terms of doing something about the change that I want to force on other people or not. And in practice, if there is let's call it a project C, and depends on, some library or something, is Pants going that far that the person which is making the change and introducing new version of the library, should that person propagate that change across the projects or do something about it, or make it just easier for the other folks to grab the newer version?
Well, generally in a monorepo, if you make a change, then with the right tooling, with something like Pants, you can run all the tests that depend on your change. Like, it is a very feasible thing to do, to say, run just the tests that could possibly be affected by my change, and you can see what you broke. Generally, I prefer the mode where it is your responsibility to fix that. So essentially, the versioning in the whole point of a monorepo is that you don't have different versions inside your code base that other parts of the code base have to depend on, because you end up with what's called jar hell or dependency hell, where you have transitive dependencies at conflicting versions. So Monorepo is designed to avoid that transitive dependency hell problem. So the flip side of that is, your repo has to be internally consistent. The right tooling allows you to achieve that internal consistency fairly easily, because you can reason about what are the possible effects of my change, where could they ripple out to. In a multi-repo situation, it is very hard to know that. And you still have the dependency hell problem, because if you have hundreds of smaller repos and you rely on versioning to figure out your dependencies, pretty soon you're going to get exactly that transitive version conflict problem again, except without any tooling to help you resolve it. So generally, philosophically, I believe that if you make a change in a monorepo, you are responsible for how it propagates downstream. And the tooling allows you to do that. It is very easy to say, well, just run all the tests that could possibly be affected by my change, and let's see what breaks.
Yeah.
Obviously, if you have no idea how to fix it, you bring in other people.
Now I understand that my question was without the monorepo in place, but with let's call it polyrepo approach.
Let's say in polyrepo, you are kicking the can down the road to other people when you make changes. And I think as a person who is administering a code base, let's use the word code base to mean either your monorepo or the sum of all your polyrepos, your responsibility as the architect of that thing is the cohesion of that code base across your entire team. And I don't think it is viable in the long run to just sort of create essentially low-level conflict between different code base owners over who is responsible for what, and to say if you want to upgrade, you have to resolve a dependency hell problem every time. That's generally why I lean towards monorepos.
Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. Going back to PANs and build systems, I myself don't have a lot of experience with compiled languages. My personal experience are around Ruby and then Elixir, which is a compiled language. But yeah, the ecosystem and that where we use is kind of specific. You mentioned about introducing high-level concepts where each unit of work during the build process can be fingerprinted and atomized and then later reused, which could save a lot of time. Can you give us maybe a bit of concrete example? What can be used and what are those high-level abstractions the system allows?
So the classic example is running tests, because all languages have that. And ideally, you have a good amount of tests in your code base. And if not, then go away, write a bunch of tests, and then come back and finish listening to this podcast.
Absolutely.
But it really is the difference between, okay, I've made some changes. Basically, in most of today's build setups, I have to run all the tests. And I have to run them one at a time, because the system can't reason about what tests could potentially be impacted by my change. So it has to rerun them all. It doesn't know how to cache them, the results, because it has no key, has no coherent sense of a key to cache against. As I mentioned, the state of your build in a system like make, say, is the state of the entire file system, or the relevant part of the file system. And it can't run concurrently because it has no way of knowing what the work dependencies are, what work affects other work and therefore has to complete before the other work can complete. Because these systems all rely on side effects onto the file system. So if you run something too soon, the file that it was expecting to be at some magic location on the file system may not be there yet, or the wrong version of it may be there. PANS takes the approach of, no, this needs to be modeled as an explicit workflow. So basically, it knows about all the static code dependencies. It knows that this test imports this file, and this file imports this other file, and so on transitively. So it knows which changes to which files affect which tests. It also knows all the other inputs needed to run a test. So in Python, for example, the standard test runner is called PyTest. So it knows that, to run these tests, it needs this specific version of PyTest that has been previously fetched and cached somewhere. It knows that there is various configuration that goes into running tests, like what are the timeouts. In PyTest, you have this conftest.py, which adds all sorts of extra configuration and plugins and so on to your PyTest runs. The system knows about all of these things. So it looks at those and it says, okay, all of these inputs have been resolved. To make the example more complicated, let's say that you have tests that depend on generated code. So you have a protocol buffer IDL, and you need to run the protocol compiler to turn that into Python code. The system knows that. So it can say, okay, I cannot run this test until I generate code because it depends on the outcome of generating this code. So it knows that it can't run the code generator and the test concurrently. But once it has run the code generator, it looks at all the tests and says, well, none of these tests depend on each other, which is obviously the healthy way to write tests. So I can run them concurrently. And furthermore, I can cache them against all those transitive inputs I just mentioned. If any of them change, I have to rerun them. If they don't, I can resolve them from cache. Furthermore, let's say now someone makes a change to that protocol buffer ITL that I mentioned, but it's just a white space change, or they added a comment or something. The file has changed, its fingerprint has changed, so the system knows that it has to rerun the generator. But when it does, it sees that the file hasn't changed. That was just a white space change in the source. So the resulting Python file is identical. So its fingerprint is identical as some previous result that we have. So we don't need to run those tests again, even though we did have to rerun some precursor to the tests, but the tests themselves, their own inputs haven't changed. So we can shortcut all of that work. That's what I mean by treating a build like a workflow. Does that answer the question?
Yeah, absolutely. And just to try to explain this to myself, how it works in practice. So for various high-level entities, as generating, let's say, a client library based on some gRPC specification, which is, potentially dependency, and I maintain that. And when you say test, with various languages, one of the unit of grouping tests are test files.
Yes.
And then in that test file, well, actually, there are then, concrete tests. Can be unit, can be, any level, but, a test case. Let's use that terminology. Is Pants providing a support that go to that granular level of individual test case and potentially saying, okay, what might affect this? Or it's on the level of file, or potentially I'm missing something out, which is a bit bigger in the picture.
That's a very insightful question, and you're not missing something out. Right now, everything I mentioned in terms of caching concurrency is at the file level. Pants does not look inside your test files and break up the work within a single file, although it could on a case-by-case basis. Like that could be, say, so in Pants, there's generic support for running tests, and then there's the Python implementation, if you will, of that for PyTest. Potentially, if there was demand for it, we could add support, assuming PyTest allows us to hook into their introspection and actually run different parts of the file concurrently and cache them separately. But we are looking into a kind of the opposite of that, which is right now we run, to get that concurrency and caching, we run PyTest concurrently once per file. And so it may be, depending on how your files are laid out, that is either too granular or not granular enough, in which case we either need to go inside a file or we need to group files together. And so that's kind of an area of ongoing research. But right now, everything happens at the file level.
Yeah, okay, that's clear. And I think that also some of, if not majority of our listeners have some experience with trying parallelizing their test suite. And yeah, it usually happens in one way, with some tool or by hand, you run different subdirectories, and try to get around that and maintaining that. If I imagine an application, a couple of years old, having hundreds, if not thousands of test files, initial implementation and maintenance of that specification in Pants, is it something which is reasonably easy?
We put a lot of effort into making it reasonably easy. So the thing about the build tools like Pants, the sort of more modern ones, is they do require a lot of metadata and boilerplate, because you have to tell the system about dependencies particularly and other information. You have to kind of teach it the structure of your code. The sort of graph of your code dependencies isn't explicitly modeled, right? You can't, it's not like on the file system. It's not implied by the shape of the file system. So that information has to live in these build files. We know from our own experience that maintaining those is a giant hassle, especially when you start trying to adopt a new tool. So we have several mechanisms for making this much, much easier. The first and probably most important one is dependency inference. So unlike other tools, we do not require you to explicitly enumerate your dependencies in those build metadata files if we can infer them from your import statements. So at runtime, we would just look at your imports, and any time, which is 95% of the time, when a dependency is really just repeating something we can infer from looking at the import statements in your code, we just take it from the import statements. Occasionally, there's a dependency you can't infer, like sometimes you load code by name at runtime, or you depend on like assets that are not imported. There are cases like that. So in those cases, you have to potentially manually add those dependencies, but 99% of the time you don't. And also, That logic is itself pluggable, the dependency inference logic. So for example, Django has various naming conventions where code is loaded at runtime based on names, like models have to live in models.py, migrations have to live in a migration subdirectory. And so you can teach the system that kind of thing. So the big one is dependency inference. The second is we have sensible defaults for things. So when you declare this directory contains a Python library or a bunch of Python tests or whatever, it knows that tests are typically called test underscore something or something underscore test or test.py or conf-test.py for configuration. So it knows that, and it knows that everything else that ends in .py or .py is a library or so on. So it has sensible defaults. And then the third thing, which we just released, our most recent pants release is 2.3.0, and it is the first to contain this feature, which is something we, in a not great pun, called the tailor feature, because it helps you make your pants. Tailor basically generates those build files, even those much smaller build files that don't need to contain dependencies and mostly have sensible default values. It generates those by looking at what files you have. And it's idempotent, so you can just keep running it as you go, and it will add new build metadata as it goes. And again, sometimes it'll get it wrong and you'll have to manually tweak what it generates. But for the most part, it gets you going and gets you a long way to get started. So with these features, we've put a lot of energy into making it much, much, much easier to adopt this kind of system than it's ever been. And that continues to be an active area of work for us because we will not rest until it is really, really easy.
Yeah, it must be. Otherwise, developers will not like it. You mentioned two things as part of our prep call, two things more. One is the support technologies. So you mentioned now Python and Scala being in V2 seems like first things. And you also talked about extensibility and supporting other technologies. Can you give us a kind of a roadmap in terms of technologies and how you see it? And the other thing is maybe give us a brief overview of how potentially someone could extend the system and support something new.
So the core engine, the workflow engine that I've been talking about, is written in Rust for performance, but the API to it is a Python API. So actual build logic is written in Python. So the Pants project provides obviously the Rust core, and it provides a set of official, if you will, build rules, which, like I said, are currently focused on great many Python use cases. I've mentioned several like tests, but it also knows how to run 6 or 7 different linters and formatters, and it knows how to build wheels, and it knows how to build these Python executable files, and it knows how to build AWS Lambdas, and there's a lot going on there. We're currently also working on JVM support. But anyone can write. Plants is fully extensible and has this plugin architecture. So anyone can write their own rules using the exact same APIs that the official rules use. So this is useful in many cases, but two that stand out are, first of all, many organizations have custom build rules. People have custom code generators or custom linters or custom checks. So you can just write code to do that. So one example is we get asked a lot for Docker support. And then when we dig in to see what that means, it turns out every organization has a bit of its own sense of what it wants out of Docker support. And we will probably coalesce to official Docker support at some point this year. But for now, we're just helping other teams write their own kind of Docker support because, again, it means something different to everyone. So one case is everybody's got their custom build rules. But the other is if there's a language or a library or a framework that's not supported and you want to add support. We're an open source project and we obviously welcome contribution. Anyone who wants to add functionality that's useful to them and maybe useful to others is welcome into the sort of official code base. And that could include anything from there's this one Python linter that I'm going to add to your list of 6 or 7 linters you support. Or it could be, I want support for a new language. I want support for Ruby. So I'm going to add support for Ruby. It could be anywhere on that spectrum.
Yeah, great. Okay, so folks can head to, what's the URL?
It's pantsbuild.org. And you can also find me on Twitter. I'm at Benjy, Benjy, or benjyw@gmail.com. And the best place to ask questions about Pants, though, is Slack, Workspace, which, again, you can find the links to at pantsbuild.org.
Great. Yeah. And if your tech stack is not supported, you can potentially contribute and get started using Pants.
Yep. We welcome new users and new contributors and, new memes.
Great. Okay, thank you, Benjy, for sharing all this. And yeah, good luck with the project.
Thank you. Thanks for having me on. This was great.